everyone, thank you so much for coming to this video. So today we're going to be working with arithmetic sequences and series. So just make sure you've understood the work we did about just the overview of sequences before you come to this video. So the learning objective for today is to be able to understand and work with arithmetic sequences and series. Like always, there will be timestamps in the description of the video, so feel free to skip to any parts you want to. So firstly, what is an arithmetic sequence? So arithmetic sequence is just one where you're adding the same amount to each term of the sequence. So it could be like 1, 3, 5, 7, etc., or like 2, 4, 6, 8, etc., when you're just adding 2 to each terms. And then if we were to generalize this, so we can work out like a general formula for the nth term, you could generalize this by saying like, so the first term of a sequence, that you could just call that as A. So yeah, so in this one, A would be 1, and for this one, it would be 2. And then because you're adding this, so for this one, you're adding 2. So for both of them, we're adding 2 to each one, to each term. So then your second term would just be A plus D, with D being the amount you're adding to each term. And then your third term would just be A plus D, and then you're adding the same. So that you're just adding D to your second term. So your second term is A plus D, so you'll just add D to that. And that's just the same as A plus 2D. And then your fourth term would just be your third term, which is A plus 2D plus another D. So it's just A plus 3D. So now if we were to simplify this in order to work out what the UN was, the nth term of the sequence, we could just, using what we have here, we know that for each term in the sequence, as we continue, this would just be A plus 4D, A plus 5D, A plus 6D. So you know that each nth term of the sequence would have A. And then you want to add something on. And then we know each one has a D as well. Well, every one apart from the first one have D. And the value of D is just what the term of the sequence is minus 1. So it'll just be n minus 1D. So that's just how you write the nth term of the sequence. So with the first one, because n is 1, that cancels out. So you'll just end up with A. Your second one, n is 2, so you get 2 minus 1, it's just D. So that's how you write out what the nth term of the sequence is. This is your formula for the nth term of the arithmetic sequence. So just make sure you memorize this. So let's try a question to see if you've understood how to apply this. So we have a question here. Feel free to pause the video and try it out for yourself. So we want to find the 20th term of the arithmetic progression 2, 5, 8, 11, and we want to find the formula for the nth term. So we know that the formula would just be in this form here, UN equals A plus n minus 1D. So the first thing we want to do is find what the values of A and D would be. So we know that A is just what your first term in the sequence is. So your A would just be equal to 2. And then to find what D is, so if we write out the sequence here, D is just how much you have to add, or the common difference between two terms. So to get to 2 to 5, you have to add 3, and then similarly 5 to 8, you have to add 3. So that means your D is equal to 3. So then if you write out the formula for the nth term, you would have UN is just equal to 2 plus n minus 1 times 3. So then if we were to find out what the 20th term is, what U20 would be, that would we can just plug in n equals 20 into this formula. So we'd have 2 plus 20 minus 1 times 3, which is just 2 plus 19 times 3. And that would just be equal to 59. So that's how you solve a question using the general formula for an arithmetic sequence. So moving on to arithmetic series, if you remember from the other video on sequences, we learned that a series is just the sum of all values in a sequence. So then if we were to try and find out what the general formula of an arithmetic series would look like, what we can do firstly is just write out what arithmetic series would look like generally. So we can write out that the sum of n, so s of n, and that's just equal to the first term, which is a, plus the second term, which we learnt previously was a plus d, plus a plus 2d, plus a plus 3d, all to a plus n minus 1d. So this was just the formula we got last time. So it'll go up to whatever we have n is. And then we can also rewrite this as L, which is equal to the last term in a sequence. So then if we were to rewrite this sequence, we would have A, and we would also have all the way to L. So if we would have A plus D. And then if we were to do going backwards, what the sequence would be like, the second last number in the sequence would just be L minus D, and then the second last would just be L minus 2D, and this would be A plus 2D, and this would just continue and eventually would reach, and this could also continue the other way, so they would eventually reach to be equal. And so then if we were, so this is also equal to Sn. And then if we were to rewrite this equation, but in reverse, we would have L plus L minus D plus L minus 2D plus A plus 2D plus A plus D plus A. And then if we were to sum these two SNs together, we would have 2SN. That's just equal to, if we do A plus L, that's just A plus L. And if we do A plus D plus L minus D, that would also just be A plus L because the D's is cancel. And if we do A plus 2D plus L minus 2D, that would also be L because 2D would cancel. And that would go all the way sum, and then we do L minus 2D plus L plus 2D. D's would cancel again, so we'll just get A plus L. And then we would, and then if we do this, L minus D and A plus D, we'd get A plus L again. And then last time would be A plus L again. So then we will just have n number of A plus L's, depending on what n would be. So you can simplify this to A plus L. So you'll have 2SN, which is m is equal to n times A plus L. So then we subtract, if we divide 2 by both sides, we just have n times A plus L is just equal to over 2, and that's just what Sn is equal to. So that's just the general formula for what the sum of an arithmetic sequence or an arithmetic series is. So that's the general formula, and you could also rewrite this in another form. So as we say here, L is equal to A plus n minus 1D. So if we were to sub that into here as L, we would have n A plus A plus n minus 1D all over 2. So then we would have n 2A plus n minus 1D all over 2. Yeah, that's just two ways to write out the formula of an arithmetic series. So you would get this formula in your formula booklet, so don't worry about memorizing it. But if they ever ask you how to prove that, this is how you would do it. So now let's move on to a question to see if we can apply this. So we have this question here. So for the arithmetic sequence -5, -2, 1, 4, 7, find the sum of the first 20 terms. So if you want to pause the video here and try the question out for yourself. So we want to find the sum of this sequence for the first 20 terms. So we want to try and find what, did this in another colour, what S of 20 is. So to do this, if we were to use either one of these formulas, we can't use this formula because we don't know what the last term is, so we're going to have to use this second one here. But to do that, we need to find out what A and D is. We know that N is 20, so that's okay, but we just need to find out what A and D is. So A is just the first term in your sequence, so it's just -5. And then D is the difference between each term in your sequence. So to get to -5 to -2, you plus 3, to -2 to 1 is plus 3, 1 to 4 is plus 3. So our D is equal to 3. And then we can just plug this into our equation. So then we would have S20 is equal to N is 20, so 20 divided by 2. Then in brackets we would have 2 times -5 plus, N minus 1, so 19 times 3. And then if we were to put that in your calculator, you would just get that as equal to 470. So that's the sum of the first 20 terms. So yeah, as long as you know what the formula is, it's not that complicated. You just need to plug in the values into the formula. So yeah, don't try and memorize the formula, but if you can't, it's okay, because you'll get this in your formula booklet. So let's try an exam question. Feel free to pause the video and try it out for yourself. So we have, in an arithmetic progression, the sum of the first 10 numbers is 400 and the sum of the next 10 terms is 1000, and we want to find the common difference and the first term. So here we just want to try and use the formula to see if there's any way we can make an equation maybe to try find a common difference and first term, A and D. So yeah, just for this one we want to use this second equation again because they haven't given us any word about what the last term could be. So let's just write out everything we can. So the sum of the first 10 terms is 400. So S of 10, that is equal to, we write out what S of 10 is using this formula. We would have 10 over 2, and then we have 2A plus 10 minus 1, so 9D, and that's equal to 400. So that's also, we have 5 times 2A plus 9D is equal to 400. And then we can always divide 5 from both sides. So we'd have 2A plus 9D is equal to 18. So that's an expression for the first 10 terms. And then it's saying the sum of the next 10 terms is 1000. So if the first 10 terms, the sum is 400, and the sum of the next 10 terms is 1000, you know that that's 20 terms in total, and the sum of all 20 terms is 400, the sum of the first 10 terms plus the sum of the next 10 terms, so 1000. So the sum, so then you know S20 would be equal to just the sum of them both, so 1400. So if we plug in the values here, so we'd have 20 divided by 2 times 2A plus N minus 1, so 19D, and that's equal to 1400. So then we would have 10 times 2A plus 19D equal to 1400, and then if we divide 10 by both sides, we would get 2A plus 19D is equal to 140. And now we just have two simultaneous equations that we can solve to find A and D. So if you label this 1, label this 2. So both A have 2 in front of it, so we can just do equation 2 minus equation 1, and then you would get 2, and the a's will cancel, and you get 19d minus 9d, so that's just 10d, and then 140 minus 80, that's just 60, so then your d is equal to 6, and then you can just plug that back into, let's say, equation 1, so then we would have 2a plus 9 times 6, that's equal to 80, then we have 2a is equal to 80 minus 54, so that's just 26. So then a is just equal to 13, and that's your answer. So you have your first term a is equal to 13, and your second term d, your common difference d is equal to 6. So this question may have seemed a little bit confusing at first, but all you do is you just try and write down all the information you can, knowing any formulas you can use, and then see if you get something that you can solve. Like we got 2 simultaneous equations from that, which we know how to solve. So if you've forgotten how to do simultaneous equations, make sure you review that lesson. But otherwise, yeah, that's how you'd answer this question. So thank you everyone, hopefully you found this video really useful. So just to sum up, we learnt the general formula for the nth term of an arithmetic sequence, and also the general formula for a series, an arithmetic series. So make sure you do many practice questions just to make sure you fully understood everything. Thank you.